Here's a nice looking equation. Let's see if we can solve it. How about if we distribute this 5 through and then the negative 6 through? It's really a 6, but it's subtracting. I'm going to think of it as negative 6. So take that 5 through. So doing so, we will get 5 times a, I'll write as 5a, plus, right, plus, and then 5 times 4 is a 20, minus, now here's what I'm doing. I'm taking negative 6 and multiplying it to the a, right? So I'm going to get negative 6a, and now I'm taking negative 6 and multiplying it over to the 3. Negative 6 times 3 is negative 18. So minus 18 equals negative 2. Let's combine terms on the left side. 5a's minus 6a is negative a, negative 1a. Don't need to write the 1, negative 1a. And then 20 minus 18 is plus 2. That's all equal to negative 2. Now we're almost there. I've got negative a plus 2 on the left. I want to eliminate this 2 here. Let's eliminate the 2. It's plus 2. So I'll undo the addition with a subtraction. So I'm going to subtract 2. Now here's how I'm going to do this. I'm just going to say what I'm going to do. Now this is really in my head. All right, this is when we do these problems, that's in your head, and you're just going to do it. You don't need to write every single step. You're going to get negative a. Now plus 2 minus 2, right? Plus 2 minus 2 is 0. That's gone. I don't even need to write the 0. Equals, now, subtract 2 from this side. So you have minus 2, and then you got negative 2, and then minus 2. Negative 2 minus 2 is negative 4. And now over here, this happens a lot. Let's be sure we've got this. This is negative 1 times a is equal to negative 4. So you're multiplying this a by negative 1. Now there's two things you could do. You could divide by negative 1, or you could multiply by negative 1. I think most of us just think about multiplying by negative 1. So that's what I'm going to do. I'm going to multiply by negative 1. Now, if I multiply this side, right, negative 1 times negative 1, all right, again, you know, this is in our heads. That's what I'm thinking I'm going to do. And then again, negative 1 times negative 1 is positive 1. I don't need to write the 1. I'll just write the a. Equals, and now over on the right side, I'll get negative 1 times negative 4 is positive 4. And I think that's the solution. Now, I could always check it, right? I might want to run a check. So I'm going to check this. I'm going to rewrite the original equation. Whoops. I'm going to rewrite the original equation, but, okay, so the original equation is equal to negative 2. Let's see if I can get this thing to right. All right, now, put in, what do we get down here? Put in 4. All right, so I'm going to say when a is equal to 4, here's what we get. We get 5 times, now put that 4 into here and put it into here. So we will get 4 plus 4 minus 6 times 4 plus 3. And now the way I do this, I write a question mark if that's equal to negative 2. I don't know that it is yet. You know, if I do this, if I just write that, then I'm claiming it's true. But I don't know that it's true just yet. So let's undo that. So now multiply through. Well, let's combine first. So how about 5 times 8 minus 6 times 4 plus 3 is a 7. Is that equal to negative 2? 5 times 8 is a 40 minus 42. Is that equal to negative 2? 40 minus 42 is negative 2 equals negative 2. It checks. All right, so now we will actually conclude that a is equal to 4. Let's solve for x in this problem. Now notice that we've got an equation because we have an equal sign. Let's start by, now we've got a multiplication, and an addition. I can't do anything inside because these are opposite, these are unlike terms. So let's try the multiplication. So I'm going to send the 3 to the 4x and to the plus 5. All right, so we are going to have 3 times, now I'm going to write out what I'm doing. 3 times 4x plus 3 times 5 is equal to 2. Now normally you could just go to this step right here. 3 times 4x, 12x, plus 3 times 5 is 15. So that part there might just be in your head. And the whole thing's equal to 2. Now, let's undo in the opposite order of operations. So the order of operations said we would multiply, then add. So to undo, to get the x alone, let's reverse that. let's undo the addition, then we'll undo the multiplication. So the first thing I'm going to do here is I'm going to subtract. This is just what I'm thinking. I'm going to subtract 15, all right? That's our thought. Now, if I subtract 15, this is what it would look like. This is what's in my head. I probably wouldn't write this out, but I subtract 15 from both sides, so that's just in our head. Then what do you get here? 15 minus 15 is 0, and 12x plus 0 is just 12x, right? So you can go right from here right to here. And then this is equal to, now on the right side over here, 2 minus 15 is negative 13. Now, one more step. I'm going to divide by 12, right? I've got a multiplication, so undo the multiplication with a division. So let's divide by 12, all right? That's what I'm thinking. Now, here's what would be in my head. Okay, I'm thinking I've got 12x, I'm going to divide it by 12, and on the right side I've got negative 13, I'm going to divide that by 12. So this again is in our head, and as I think about this, I'm doing that so that those will cancel. So now I end up with x is equal to negative 13 over 12. And I'm going to claim that that is my answer. Of course, I should check it, but I'm not going to do that in this problem. Problem 9 asks us to solve for k in this equation here. 47 is equal to k over 32. Now I notice I've got a division, right? K is divided by 32, so I want to undo that division to isolate k. So it's a division, so undo a division with a multiplication. So here's what I'm thinking. I'm going to multiply by 32. Now it'll look like this. Here's what I'm thinking. So 47 times 32 is equal to 32 times k over 32, right? This is what we're thinking. And we're going to do this because that 32 will cancel with that one, leaving us with just k. All right, so let's do this now. So 47 times 32. All right, so this part here is just in our head. Now, 47 times 32. Got your calculator? I put in 47 times 32, and I got 1504 is equal to k. I'm going to claim that that is right, and that should be okay as long as I put the right numbers in the calculator. Problem 10. Let's solve for p in this equation here. 100p equals 2800. Now in this case, p is being multiplied by 100, so I'm going to undo that multiplication with a division. Now this is the opposite of what we did back here in problem number 9. The variable k was connected to a 32, so we used the opposite of division was multiplication, so we divided. Now in this case, what we're going to do is we are going to divide by 100. Right, so it's going to look like this. 100p divided by 100 is equal to 2800 over 100. All right, now that's all in our head. The 100p's cancel, and now we're left with p equals, now when you divide by 100 or tens or anything, you just kind of get rid of some zeros. So what I can do here is cancel, cancel, so I get 28. So let's write that. P is equal to 28. And that one I can check in my head. Right up here, what are you going to get if you put in 28? What's 100 times 28? 2800, I got it, it checks. All is good.